There are some topics in math that are so fun, you want to watch them twice. We're going to do some more systems of equations. Everything that we introduced in the 95 video, we're going to build upon here. If you haven't watched the 95 video on systems of equations, do that first. It's the same material, same topics. We're just going to expand on them now, giving some help on this 96 assignment as well. Okay? We're going to start with number 5. Write your work and answer in the space provided. Upload this document on Canvas when you're finished. Solve the system graphically by graphing both equations and seeing if they intersect. If it has one solution, give your answer as an ordered pair. If not, state either no solution or infinite solutions. You must show the graphs. So number 5, we have 2 graphs, or 2 lines, 2 equations. One is already in slope-intercept form. The other is not. And that's okay. So let's graph this first one first. Slope-intercept form. Remember, y equals mx plus b. M is the slope, and b is the y-intercept. That's where it crosses the y-axis. If it crosses the y-axis at -3, this is our y-axis, this is our x-axis, and -3, it crosses the y-axis here. That's what that's saying. And then the slope is -3/2, which means down 3 and right 2. It's down because of the negative. If it were +3/2, it'd be up 3. Rise over run. Since it's negative, the rise is negative rise. Falling, okay? All right, so down 3, 1, 2, 3, and right 2, 1, 2. Down 1, 2, 3, right 2. Or we could go the opposite way, up 3 and left 2. Up 3, left 2. And we get this kind of idea. All right, you connect this as a line. I'm not super good at drawing lines, but do your best. The more accurate your line, the better, the more accurate your answer is going to be. Now for the second one, you could do it a couple ways. You could also put this in slope-intercept form, could solve for y. But you don't have to. There's other ways of doing it. Another way to do it is to make a table. So just to give you guys more things to see, instead of solving for y here, I'm going to make a table. You can plug in any x value and any y value. I'm going to plug in a couple x values and see what y has to be. For the equation, 4x minus 2y equals -8, if x is equal to 0, for example, what does y have to be? Well, if x is equal to 0, we can solve for y. 4 times 0 is 0. That just leaves us within -2y equals -8. Divide both sides by -2 to get y equals +4. So the point 0, 4 is on the graph. That's this point right here. It's on the graph because if x is 0, y has to be 4. The ordered pair 0, 4 is a solution to this equation, meaning it's a pair of x's and y's that make the equation true. And now we can go through the same exact process for the other x's. I'll go through one more fully, and then the final couple I'm going to run through very quickly. So if x is equal to 1, there's going to be a different y. So replace x with 1. And follow the same steps to solve for y. So this is a 4. So we need to subtract 4 from both sides. Now we need to divide both sides by -2. And we're going to get y equals +6. Turns out the next ones are going to look like this. Again, this means the point 1, 6 is on the graph. And then these other ones, this one has a slope of +2. If you put a whole bunch of points, it's going to look something like this. And where do they interact? Sorry, where do they intersect? At this guy right here. Maybe that's a little bit big. That's the point -2 comma 0. The negative 2, comma 0 is our solution. There's one solution to this equation. You could also use the elimination method or the substitution method to do those. We used a graphical method to solve this, but those other methods are analytical methods, just with equations and algebra, but no graphs. You should get the same answer. Furthermore, if we plug in negative 2 and 0 into both of these equations, should make both of them true. All right. Next up, let's go to number 8. Write your work and answer in the space provided. Okay, very similar instructions. But this time we're going to do analytical methods. So we can either use elimination or substitution for this one. All right. So let's use substitution. It's a pretty nice substitution because we already have something that's solved for y. To do elimination here, you could multiply both equations by 2 and then subtract them. Sorry, you could multiply the first equation by 2 and then subtract them. If you multiply the first equation by 2, you get 2y equals negative 6x plus 12. Right? That's what happens when you multiply this equation by 2. And then you could take these two equations and subtract them. Well, we've already done it. Let's just keep going. All right, so the first equation minus the second equation. So we're subtracting 2y, subtracting a negative 6x, and subtracting a 12. So when we do that, this equation, when we subtract everything below it, still has a 6x, plus 2y minus 2y cancels out, equals, we now have a positive 6x, plus 12 minus 12, cancels out. We get 6x equals 6x, which is a little weird. We want all the x's on one side, so let's subtract 6x from both sides. And we get something really weird. 0 equals 0. What do we do with this? Well, remember what we're doing. We're trying to solve this system. We're trying to find the x and the y that make this true. What does x have to be for 0 to be the same thing as 0? What does y have to be for 0 to be the same thing? This doesn't depend on x and y at all. X and y don't matter here. 0 is always going to equal 0. Okay, there's infinitely many solutions. This is always going to be true. Anytime that one of these is true, the other will be true as well. Okay, so infinitely many solutions because this is always true. Infinitely many solutions. And then make sure to write the right answer in Canvas. So these are actually the same line. If you graphed them, I mean, let's just graph them right now. Why not? I'll show y'all. If we get y equals negative 3x plus 6, it's that green line over here. And if we graph the other one, 6x plus 2y equals 12. You can see, yep, they're the same line. Infinitely many solution. Anything that's on the line will be on both lines. So technically our answer should be infinite solutions. All right, let's do 2 more. Number 10. All right, we did the elimination method. Let's do the substitution method. Why? Because we've already solved for y. Makes substitution a lot easier. So you have to solve for y and then replace the y in the other equation with what y equals. We have x plus 4 times y equals 5. And we know that y is the same thing as negative 1/4 x plus 3. Right? That's what y equals according to this equation. If they're the same thing, we can do a swap. I can't snap with my left hand. And my right hand has my glove. Okay, I can snap a little bit. I snap with my index finger. All right. Y is equal, the same thing as negative a quarter x plus 3. Now we can just solve this equation. So we have to follow order of operations. We can't simplify inside the parentheses, so we have to start by distributing. We get x, 4 times negative a quarter x is negative 1x. 4 times 3 is positive 12. The right-hand side stays alone. It might help to write a 1x here. We have 1x minus 1x. Now we have 0 x's. We get 12 is equal to 5. Something similar to what we have up here, but a little bit more alarming. Up here, I said 0 equals 0. That's always true. Well, what does x and y have to be for 12 to equal 5? But that's never true, right? That's never, ever going to be true. 12 is never going to be equal 5. I don't care what x value you choose and what y value you choose. This is never going to happen. There's no answer here. There's nothing that's going to make this true. There's no solution. And graphically, this would look like 2 parallel lines. These are going to look like this line. And the other line is going to look like, I don't know, maybe this line, something like that. They're going to be parallel. They're never going to cross. So that's something to watch out for in these sorts of things. Let me know if you have questions about that. Last thing I want to look at is number 12. So it just wants to translate into a system, and it doesn't want us to solve. If Jackie has a total of 37 pets, and all of those pets are either dogs or fish, that's one piece of information. The second piece of information is that the number of dogs she has is 5 less than half the number of fish she has. How many fish and dog does she have? We can solve this question by putting it into a system of equations. Now, my advice for any math multiple choice question ever, any math multiple choice question ever, if you have more than 5 seconds, because if you have 5 seconds, you can just guess. If you have more than 5 seconds, don't even look at the answers. Just do the problem and then see which answer matches. So each of these pieces of information is going to be an equation. Let's look at this first one. There's a total of 37 pets, all of which are dogs and fish. Let's let D be the number of dogs, and F be the number of fish. So if you add up all the dogs and the fish, you should get 37 pets. Dogs plus fish is 37. That's what that first equation means. The second equation is the number of dogs she has is 5 less is, sorry, I'm getting ahead of myself, 5 less than half the number of fish. Anytime you see the word is, that means equals. So the number of dogs is means the number of dogs is. Number of dogs, D. Is equal sign. 5 less than, and this is where things get trickier. Less than is kind of like a minus sign, but 5 less than is take the thing and subtract 5. So 5 less than half the number of fish is going to be 1/2 the number of fish minus 5. Okay. And if you're ever curious about the order on that, just give some examples. You could say 3 is 5 less than 8. But if you wrote it like this, that wouldn't make sense. Not true at all. So 3 being, this is just a silly example without variables to show the order of what these words mean. So 5 less than must be in the other way around, right? 3 is 5 less than 8. Less than must mean a minus 5 at the end. That's just a little trick that I use. And I really, truly do use that trick because sometimes the wording confuses me too. English is hard for me. I'm a math guy, not an English guy. Okay, so that's a good thing to do. So now we have a system of equations that we could use to find out how many dogs and fish Jackie had. And hopefully this is one of our answers. D plus F is 37. That one's out. All the other three have the right first equation. And the second one is D is 1/2 F minus 5. There we go. And be a little careful with these because just because the equation doesn't look the same doesn't mean it's not the same. So both of these other equations are solving for fish. So we could actually solve for fish here to make sure that they're different from what we have. We could add 5 to both sides and then multiply both sides by 2. 2D plus 10. Okay, neither of these are 2D plus 10. So we know for sure they're wrong. Otherwise, there could maybe be multiple right answers because this is the same equation as what we had, just in a different form. Let me know if you have any questions about this. Hope you enjoy your systems of equations. Have a good rest of your day. Bye-bye.